This is Thad Starner. Today we're going to talk about protoboards. Now there are many different types of protoboards. I have some of them sitting in front of me. And I'm talking about the copper plated or metal plated protoboards that you can use to actually solder down your prototype circuit board. Now Radio Shack calls these something like a general purpose printed circuit board. And they come in all sorts of different sizes and shapes. But the goal here is to take, say, a circuit that you have already made, say this circuit here, which is just a chip that's being powered by a battery, and I have an LED and a resistor to show me that the chip is being powered. I want to take that circuit, or whatever circuit, and translate it to something more permanent. You know, if I tried to use this circuit in a backpack or put it in a case, it's a good chance that one of these wires is going to come out, because they come out really easily. We don't want that. We want something more permanent, something that can actually last years at a time without a problem, even decades. So what we want to do is we want to actually solder the circuit together. Now there's a lot of different ways to do this. You can get a protoboard like this, which is basically set up to handle a chip. This is actually a socket, but what you do is you put your chip from underneath, like here, on the uncoppered side, the non-metallic side. You solder it together, and then you have lots of different paths to solder to. This allows you to make simple, small circuit boards. Then you have ones like this that are very similar to the breadboards you're familiar with. It's got 5 connections going across on 2 columns, and of course this one has 2 power rails for convenience as well. So you can actually translate your circuit directly from your breadboard to a prototype board like this with very little problem. You have lots of different variants of that. Here's another one. But then you have these more general purpose boards. This one, for example, is a through hole. It's got plating on both sides, the plating through the hole itself, but then you have to connect things together manually. This one's very nice, and it's also plated the whole way through, but it's also got metal on the whole entire backside. Now each individual hole is still isolated from the metal plate, just has a little bit of etched area around it. But having metal everywhere means that this makes a pretty good ground plane if I'm doing, say, a radio frequency circuit like Bluetooth or Wi-Fi or something like that, or higher end frequency stuff. Having the ground plane makes things a little bit less noisy. Now, we're not doing anything very sophisticated today. We are basically going to make a circuit like this. This is what we're going for. And so we're going to do it the hard way. Again, if I was doing this the easy way, I'd be using a circuit or a protoboard like this, where I could just copy my breadboard. But we're just going to do this the hard way so you can see this issue, see the issues involved. So now if we can zoom in on this protoboard, let me show you what we're going to do. Now normally what I would do if I'm putting in a chip, like the chip we're going to have here, I would actually put in a socket. And I put in the socket for several reasons. Number one, it may be that in making the prototype, I blow out my chip somehow, so that way I could actually easily replace it. Or it could be that I have a temperature sensitive chip. They're all temperature sensitive at some point, and soldering in the socket is much less temperature sensitive than the chip. So like I said, normally I put a socket in, but today I'm not going to worry about it. I'm going to show you what you do in case you actually were putting in a chip and you were worried about the temperature, just so you see that. Now I'm going to flip this one over so that we have some empty space for me to work with, and I'm going to basically translate this circuit into the protoboard. So let me disconnect my power first, and I'm going to take the chip first because that's going to be the most difficult thing to work with here. And one other thing I should mention is that you can often find these boards without the copper plating on it. That's called a perf board, and that's used for wire wrap, which we're not going to talk about today. So whenever you're looking at one of these protoboards, you really want to actually make sure it's got the copper on it. So what I'm going to do is I'm going to give myself a little bit more space than I normally would, just because I can. I'm going to lay out the circuit before I solder it in. Again, this is a very simple circuit. This is not particularly hard to do. I'm having difficulty here getting the pins in the board. There we go. So again, we're putting the components on the blank side, the non-metallic side, so we can solder onto the metallic side. Now I'm going to bend these pins just a little bit so that they stay in place, and I don't have to worry about the chip coming out. And now I'm also going to look at here what I'm doing with my power. I have a resistor that needs to come around the chip. And what I'm also going to do is bend, as you'll see in a little bit, bend the lead into the pin of the chip. Now I could just do a solder bridge. I'll do some solder bridges here between these copper circles, but solder is not quite as conductive as the metal leads themselves. So in general, when it's possible, where it's convenient, I'm actually going to use the leads of the components to make a better connection. It also helps the solder stick better, make better globs, as you'll see in a second. Now, let's see, that was the resistor. I need now the LED. Now notice it's very easy to get things upside down or mirror imaged here if you don't do this right. So I'm taking some care here to flip things over so I can see it on the right side and not make some bad mistakes, like get my LED in the wrong way. There we go. Okay, we'll go with that. So push that down everywhere. We'll come back to those in a second. And let's see here, I want these pins. Let's go my power rail and my power positive. Now these will probably come out as I'm doing this, just because they don't have to make multiple pins to hold them in, but that's okay. I know, I'm just going to put them down here so I know where they are to start with. Okay, so now I have something that looks very much like was on my breadboard earlier. And the breadboard's now empty, so now I'm going to get to the point of soldering stuff down. Now, the first thing I'm going to do is I'm going to remove some of these components so I have an easier time of it. I'll put them back in a second here. And what I'm going to do is solder the pins that are opposite on the chip first so that it holds it in place. The other reason I'm doing these opposing pins is that way different parts of the chip heat up. I'm not putting all the heat in one place at one time on the chip, and that protects it a little bit. So now I've done those two. I'm going to go up here, diagonally across. Again, I'm trying to distribute the heat as much as I can so I don't heat up any particular part of the chip too much. Now, for particularly temperature sensitive chips, you really want a good temperature controlled soldering iron. But you can see it's going quite quickly here. It doesn't take much heat to actually get the solder to stick to these holes. I could have done a little bit better job there on actually distributing my heat, but I think you get the point. Okay, so now my chip is in, it's not going anywhere. And it is a bit toasty, but it's not, it probably did not get too hot to damage it. now let me work on the rest of this. I'll do this. First, now notice I bent the pin of the resistor so that it goes over to the other side. Notice I now have a nice little glob of solder bridge, but also the wire is in there, which is going to provide a really good conductor between the two pads. Do the same thing down here. Give myself a nice bead there, and now I have them coming together. And okay, this is being a little bit inconvenient, so what I'm going to do is cut off my leads now so that they're nice and trimmed. Get rid of this one first, because this one's probably cooled off a little bit. There we go. This one as well. I can do this one next. Yep, probably do a little bit better job on that. There we go. And now what else do I have here? I need to finish up my LED. I see that came out a little bit, so I'm going to straighten it up, push it through. There we go. Same thing with my resistor. Clean it up a little bit here. There we go. This is where a pair of helping hands can help out with keeping the board off the table, but I'm not doing anything very complex here, so I'm not going to worry about it. Got those two soldered down now. I'll trim them. Notice I got some nice clean solder joints here. It's very shiny. There's no cool joints. Got two other things to do. I gotta take my negative rail here. Gotta add it to the negative here. Now again, notice that if I've been using one of these, it would have been a whole lot easier. I could have just hook into the copper traces, but again, I just want to show it the harder way so you get to see it. It's more general system. There we go. And let's see here, I need the positive rail, the positive lead. And let's see here, that's coming from this side. There we go. And I don't even have to trim this very much if I'm careful here. I might just go right into the same solder block, straightforward manner. There we go, look at that. But I really do want to get the solder all the way to that hole where it comes in. Oh, look at that, that's beautiful. There we go. Okay, so now I actually have my circuit soldered together. Let's see if it works. Let's see here. On this battery connection, the outside one is positive, and there we go. We are done. So that shows you how to go from a breadboard to a protoboard. This will now take a lot of abuse, no problem, and I will see you next time.